Big part, small tool. Let it run overnight. Only this night, it's a trap, and the cruel hand of fate has other ideas. When the machine checks the tool at the end of the operation, the program alarms out. In the morning, we arrive to an unfinished part and the red light of regret. In an ideal world, the machine would detect a broken tool and restart the affected operations using a replacement. That's what we'll do in this video, by understanding the tools already at our disposal and by making some changes to the Fusion Haas post-processor. This is one of a number of post-processor performance tweaks we've developed at CNC LLC. Let's take a quick look at the broken tool template that's already part of VPS to see what options exist. You'll find this in the Tool Offsets folder. You'll see that we have the tool number to probe, a measurement tolerance, and an action to perform. The default action when encountering a broken tool is to raise an alarm and halt the program. Instead, we can choose to set a flag, which is stored in the length offset of a chosen tool number. We can also choose to mark the tool as expired in the Advanced Tool Management System. More on that later. Lastly, the VPS template will demonstrate conditional flow control based on the broken tool flag. Now that we've filled out the template, we can press F4 to generate some code into MDI. We'll focus now on these 4 lines of code. This first line calls macro 9023, which is a Haas front-end to the Renishaw probing macros. The A24 parameter makes 9023 delegate to 9853, the tool check macro that we're primarily interested in. Macro 9853 will set the tool length offset of tool 199 to 1 if tool 19 is broken. This allows the following if statements to set the expired tool flag, variable 8019, and jump to an appropriate next action based on the value in macro variable 2199, the length of tool 199. We now have a general idea of the code that we want the post-processor to generate. So let's move on to the next building block, the Haas Advanced Tool Management System. The Advanced Tool Management configuration pages can be found in Current Commands, Tools, ATM. If you haven't used ATM tool groups before, the gist is that multiple physical tools can be ganged together into a single virtual tool number. You'll notice the ATM interface has an upper and a lower box. Press F4 to switch the cursor between the boxes. Press Insert to add a new group. The group number will be the T value used for M6, G43, etc. The tool number must be between 1000 and 3000. I'm going to add tools 13 and 14 to this group by highlighting the Add box and typing 13 Enter, then 14 Enter. F4 to switch to the upper box. For this demonstration, we'll leave the tool order set to Ordered, but you can see that the control can be configured to choose tools based upon the group lifetime limits. ATM deserves its own video to show the various behaviors you can get. To recap, the ATM group number is used for T, H, and D arguments to M6, G43, etc. ATM does not change how tools within the group must be set up. You still need to measure each one of them individually. Tools within a group may be individually expired through limits or through macro variables. Now that we know approximately what we want the generated code to do, let's look at manually making a sample program respond to broken tools. Any change that we would make by hand will correspond to some modification that we need to make to the post. Here's the part. It's a facing operation, scalloping with a 1/16 inch ball nose end mill, and a final chamfer op. We'll use the scallop operation as the exemplar for making a restartable program. First, though, we'll change the engraving tool to use an ATM group number as the tool number and enable break detection before the tool is returned to the spindle. Later on, we'll want to make this work with consecutive operations that use the same tool, as well as the manual NC break detection cycle. When setting up NC programs, I like to set Use subroutines to all operations, enable Safe Start, and use parametric feeds. This makes the initial part of the program more like a table of contents, so it's easy to restart a program at some particular operation. The modifications that we're going to make don't require that you use any of these options, but it will change what your program looks like compared to what you see here. The engraving operation starts by calling tool 1001 M6, and the control will load either tool 13 or 14 into the spindle. There are additional preparatory commands, and then the program jumps to the meat of the operation. There's a lot of motion commands, and we see a call to macro 9853 at the end. The first change that we're going to make is to add the M199 parameter to set a flag rather than to alarm out. We'll make the next edits at the top of the program since it makes the flow control much easier to follow. Once the subprogram is returned, we can check that the tool is within tolerance and jump over any error handling code. One future point of complication is we're going to need to know the line number that won't have been generated yet. We'll add a placeholder line number for the program to jump to. If the broken tool flag was set, we want to mark the tool that's in the spindle as being expired. Remember that the program uses an ATM group, so it's T1001 M6 to call the tool, but either tool 13 or 14 is actually in the spindle. Macro variable 3026 contains the tool number in the spindle, and we can use an indirect variable reference, like so, to set either 8013 or 8014 to expire the current tool. We want to jump to the beginning of the operation, and we can do that with an M99P1234. When we hit the T1001 M6, the control will choose the other tool in the group to load into the spindle. If all tools in the group are expired, the program is going to alarm out. We've made a first pass with manual edits to the program, so let's get set up to do some post-processor work. I've downloaded a copy of the Fusion Haas Post-Processor revision 44168 to a local directory. We can add a linked post directory to make the edit debug cycle easier. I'm also using Git for version control, but that's outside the scope of this video. The first thing we want to do is to figure out where that call to macro 9853 is being generated, and a simple search shows us that it only appears in a single place, in the onCommand entry function. Note also the tool-checked global variable that's being set. It'll come in handy later. Let's also figure out where the beginning and end of an operation are generated. In the parlance of the post processor, a CAM operation that you program in the UI is called a section, and there are entry functions onSection and onSectionEnd. We have a good idea where the changes to the post need to be made, but what steps do we need to solve for? As a brief aside, where do we find documentation for the post environment? Use your favorite search engine for Fusion 360 Post-Processor API documentation, and you should find this. It's the exhaustive reference on the API available, and you can, of course, use your existing posts as a guide to what is possible. Getting back to the coding problems that we need to solve, we need to know if a section, that is, a CAM operation, uses an ATM managed tool that makes restarting a possibility. Next, we're going to need to establish the restart line number and then actually emit the conditional flow control logic. Since we know that all ATM tool groups have numbers between 1000 and 3000, the isRestartable tool function is pretty simple. We just check the current section's tool number. I am peering into the future a bit since I know we'll eventually need to allow the tool to be passed in. Again, you can find documentation for the symbols, say current section, tool.number in the post-processor API reference. Let's declare a pair of functions to establish the restart line number and to eventually write the conditional logic that will jump to the restart line. To establish the restart line, we need only to emit an in number into the output, although adding a comment is helpful. If the current section isn't restartable, this function can be a no-op. It would be nice to allow the comment to be customized, so let's add that as an argument to the function. There are actually two kinds of restart points, in response to an M6 and in response to a manual NC tool break command. Write block is the typical means of adding output to the program, and format comment ensures that no problematic characters are in the output. Write block already supports adding line numbers to the output, but because line numbers are optional, we need to force them to be written. We also need a global variable to store the line number this function emits. The sequence number is post-incremented, so we need to save the current line number into a global variable before writing the comment. And turn off the forced sequence numbers. Finally, we'll return the sequence number for the comment. If you recall from earlier, the tool break command handler sets a tool-checked global variable. This lets us know that the tool has been touched off in the machine, but that we need to take action before the program continues. In write tool restart loop, we can early out if the tool hasn't been checked or if we're not working with an ATM managed tool. Now that we've managed the post processor's internal state, we can move on to emitting code. We can start writing the blocks for the if statement based on the flag set in macro variable 2199, but what line number do we use for the goto? The line number that we want to jump to hasn't been written yet. Expiring the tool in the spindle is exactly as we've seen before. As a temporary safety measure, we'll insert a stop with message command by assigning an arbitrary value to variable 3006 and including a comment on the line. The jump to the restart point is written using a variety of predefined formatting helpers. These ensure that numeric values are written with the correct letter prefixes, number of decimal places, and whatnot. It's good practice to use formatters whenever writing numeric values. The write tool restart point function can be called to insert a line number that we control, but how do we pass that line number backwards in the program output? The post-processor API has a mechanism for deferred variables called, as you may have guessed, deferred variables. It's performing key value string substitution after the fact, but through an API that ensures that the substituted value is well formatted. You can choose an arbitrary substitution key to get the future value from, and later on call the set function to store the value. Our output helpers are written, so we can begin adding their output to the program. We'll jump back to onSection to see how the M6 tool change is written. There's already a helpful local variable that computes whether or not the section requires a tool change. We'll add our restart point after the operations comment. Let's jump back to Fusion to repost the code and see that we have a line number under our control. Line 85 is now the restart point for the engraving operation. The next thing to do is to update the break control code to use the flag option for restartable operations. There's a couple of ways to write this, but I think the most flexible way is to accumulate arguments into an array. We'll move the G65, program number, and tolerance into an array. Something I figured out the hard way is that the 9853 macro doesn't work with ATM group numbers. We'll use macro variable 3026, the current tool in the spindle, instead of the section's tool number. If the section is restartable, we'll add the M199 parameter and call it writewords with the accumulated arguments. A quick repost verifies that we have the expected changes. We will return to the bottom of the onSectionEnd function to add our new flow control logic. There's another small gotcha here in that a manual NC command isn't a section, so we also need to call write restart loop at the beginning of the second and subsequent sections in case there was a pending tool checked equals true from a preceding manual NC break check. This particular quirk is the reason that the tool needs to be an optional argument to write restart loop. Repost and check. This looks like what we're expecting to see. The successful case jumps forward to line 190, while the broken tool case jumps backwards to line 85. We'll perform some final tests for consecutive operations using the same tool and for manual NC break checks. What we expect to see is that adding a manual NC break check creates a literal checkpoint. We have a restart point within the string of operations. We see that the final tool check on line 370 would jump backwards to the manual check at line 275 and not to the very first operation involving this tool. Let's build a quick program using some trace operations and then transfer the code to a machine for final validation. I don't see the expected restart loop here. It looks like we found a bug and need to add a restart loop at the end of a program when the last operation is a manual in-seat break check. We can do that in onClose. That looks plausible to me. Let's run it. As before, tools 13 and 14 are in ATM Group 1001. I've swapped out the engravers for some larger end mills to make things easier to see. Tool 13's length is set to ½ inch longer than it actually is. This will cause the tool measurement check to fail. The program calls tool 1001 and the machine selects tool 13 based on the ATM configuration. The simple trace operation runs and a tool break cycle is called. At this point, we see that the tool did not make contact with the stylus. The modifications we made to the post-processor expire tool 13 and jump back to the top of the operation. When tool 1001 is called again, the machine selects tool 14. This time, the tool makes contact with the stylus and the program is able to complete successfully. In this video, we covered tool probing cycles, the basics of the Haas Advanced Tool Management System, and made some modifications to the Fusion Haas post-processor. A final word of caution. Crashes are expensive, and there's no worse feeling than the building going thud because several tons of iron came to an abrupt stop. Proofread your programs. Use a diff program to compare old output against new output when making post modifications. Single block your new code on the machine and limit rapids and feeds. If you've made it this far, thank you for watching. I'm thinking about doing some more videos on my library of post-processor hacks. Let me know in the comments what worked, what didn't, and any other topics you'd like to see. Once again, it is I with CNC LLC, leaving you with a snappy catchphrase.